All right, guys, we're going to go on and get started. What we're doing today is x-intercept form. We're looking at x-intercept form of the equation of a parabola. Now, the reason I call this, and this version of a parabola is called x-intercept form, is because the values of p and q are the values of x that will make the function be 0. It's the values of x where it will cross the x-axis. One more page. There we go. Yeah, I skipped over that part. So we call it x-intercept form because the p and q values are the values of x where it'll cross the x-axis. And it'll give us the point p comma 0 and q comma 0. Now the axis of symmetry is going to be the point p plus q over 2. X equals p plus q over 2. Now the vertex is going to be the point p plus q over 2, comma f of p plus q over 2. So vertex is the point p plus q over 2, comma f of p plus q over 2. So that's our point. That is the vertex. So really we need to find the value p plus q over 2. It gives us the half of the x-intercept, or the vertex, and it gives us the equation for the axis of symmetry, and then we just have to find the x-intercepts. So let's see how this works. So the first thing we need to find in this here is the values of A, P, and Q. So looking at this here, what's the value of A?
-2.
Yes, what's the value of P?
-3.
-3, and Q is? Almost. 1. Positive 1. P is going to be -3 because the only way we can go from x minus p to x plus 3 is if the value of p is negative. X minus 1, our value of q is going to be positive 1 because we're going from x minus q to x minus 1. There is no sign change, so q has to be 1. So we have our values for A, P, and Q. So we do want to find the vertex, the axis of symmetry, and the x-intercepts. What? Abbreviate that. Now, the general form for vertex is p plus q over 2, comma f of p plus q over 2. Axis of symmetry, x is equal to p plus q over 2. X-intercept is p comma 0 and q comma 0. Now out of all this here, the x-intercepts are going to be the easiest to find first, because the y value at the x-intercept is always going to be 0. Because at the x-axis, the entire x-axis, the y value is indeed 0. Now looking at both of these here, what's the value of p? -3, so we'll plug it in, telling us that one of the x-intercepts is the point -3, 0. What's the value of q? 1, so the other x-intercept is 1, 0. So we can go on and plot those. Because those are the two x-intercepts, the spots where it crosses the x-axis on the graph. So p plus q over 2 and f of p plus q over 2. So that's the only spots where we can just plug stuff in. Now for the vertex, the first thing we need to find is p plus q over over 2. So the value of P is negative 3. The value of Q is 1. Now we just need to calculate that negative 3 plus 1 over 2. Well, what is negative 3 plus 1? That would be negative 2. And negative 2 divided by 2 is negative 1. So we can plug that value in for P plus Q over 2. So the x value of the vertex is negative 1. And the axis of symmetry is x is equal to negative 1. So we found the axis of symmetry, we found half of the vertex, and we found the x-intercepts. The only thing we left to find is the y value of the vertex. Now the y value of the vertex is f of P plus Q over 2. Well, P plus Q over 2 we found is negative 1. So really all we're doing with f of P plus Q over 2, or in this case f of negative 1, is taking negative 1 and plugging it back in to the function. Just like we did yesterday with our negative b over 2a. We're plugging in the values of b and a for negative b over 2a to find it, and then plugging it back into the function. Here, we plug in the values of p and q, find what that is in our p plus q over 2, and take that x value and plug it back into the function to find the value of y. Now, negative 1 plus 3 is 2. Negative 1 minus 1 is negative 2. So we have negative 2 times negative 2. Well, a negative times a positive times a negative would be, so negative times a positive would indeed be a negative, and then we times it by another negative and it becomes positive. So really we're looking at 2 times 2 times 2, which is 8. And it'd be positive because 2 times negative 2 is negative 4. Negative 4 times negative 2 is positive 8. So the y value of the vertex is 8. If we were to graph it, this is what it would look like. But again, all I'm looking for is the vertex, axis of symmetry, and the x-intercepts for this here. And we found them. Questions on this here? Get ready for the next one. So what's the value for A here? Well, A is negative 1/3, yes? What's the value of P? P would be? Positive 4, yes, because x minus P, x minus 4. Signs aren't changing from the general form to x minus 4, so the value of P is positive 4. Q would be negative 2. So what we need to find is the vertex, axis of symmetry, and the x-intercept. Well, we know the y value of the x-intercept is going to be 0. X-intercept is p comma 0 and q comma 0. X-intercept, x equals p plus q over 2, and vertex is going to be our p plus q over 2, comma f of p plus q over 2. So the first thing we can find are the x-intercepts, because what's our value of p? Yeah. 4, Q is. So we can plug those in. So we get the point 4, 0, negative 2, 0 as our x-intercepts. Now the first real thing we actually have to calculate is P plus Q over 2. So P is 4, Q is negative 2. Now at this point here we can do this in a calculator, 4 plus negative 2 all over 2, and it'll tell us the answer. If we did it by hand, 4 plus negative 2 is 2, and 2 divided by 2 is 1. And then lastly, we just need to plug 1 in for x. And calculate this here. Now the calculator, we can type this whole thing in, and it'll tell us what it is. Now 1 minus 4 is negative 3. 1 plus 2 is 3. And if we multiplied all this here together, negative 1/3 times negative 3, well, the negative and negative would make the positive. And 1/3 times 3 is 1. 3 over 3. And 1 times 3 is 3. So we have the vertex as 1, 3, axis symmetry x equals 1, and our x-intercept is the point 4, 0, and negative 2, 0. Questions on this here? We feel comfortable with this here. All right. I'm going to give you a second to try this one here, and then we're going to go. So, as y'all are working, A, P, and Q. A is negative 1, P is negative 1, and Q is negative 5. We all get that there. I'm going to start off with x-intercepts. Everybody got the y values of the x-intercepts are both 0, yes? One of the x values would be negative 1, and the other is? So we all agree that the x-intercepts are negative 1, 0, negative 5, 0? Okay. Vertex. Axis of symmetry. So now we actually have to do some calculations. P plus Q over 2. So it'd be negative 1 plus negative 5 over 2. Well, negative 1 plus negative 5 is negative 6. And negative 6 divided by 2 is negative 3. And incidentally, negative 3 is the middle between negative 1 and negative 5. Because that's really all it is. The vertex in the axis symmetry is going to be in the exact middle of our two x-intercepts. Now the last thing we have to do is plug this back in. So we'd have negative 3 plus 1 times negative 3 plus 5. Well, negative 3 plus 1 is negative 2. Negative 3 plus 5 is 2. Negative times negative 2 would be positive 2. And 2 times 2 is I think it should be just 4. Yes. There's a negative in front because A was negative 1. So we have that negative. Yeah. So it'd be negative 3. Make sure I'm. Yep, plus 1. It's going to give us positive 4. Questions on how we found the vertex, x-intercepts, and axis of symmetry for this here? Questions on anything we've done so far today? We feel comfortable with this here. Do we need to see another example of this here?
We have
Yes. So, if we feel comfortable with this here,
Should I get a calculator?
yes. You have the rest of the class time to work on the assignment. 1 through 4, find the vertex and axis of symmetry. 5 through 8, use the axis of symmetry to match the equation with its graph. So 5 through 8, your final answer is going to be A, B, C, or D. Problems 9 through 12, find the vertex and axis of symmetry. And 13 through 15, find the x-intercept, vertex, and axis of symmetry. I will also post a copy of this in Google Classroom, so if you lose it, you do have a copy of it there.